So instead of saying mass, we say inertia, and I use a capital I. And if I put proper units in, I can call it an exact equation. So how much rotational acceleration you're going to get something pick up, will depend upon how much torque you put on it, but how much rotational inertia does that something have? It turns out that rotational inertia is complicated. And we're just going to get the idea of it today. Rotational inertia is mr squared, the mass multiplied by the distance from the rotational axis, when the mass is localized. Ordinarily, for different shapes, it's a more complicated equation, and we won't get into that. But I can kind of show you that with this idea. Here I've got a couple of plastic pipes. And in these pipes I've got some lead. And I'll tell you, the same amount of lead in each one. Could I have a helper, please? My helper today, gang, this is Tenny Lim. She's the lady in the energy chapter who's pulling the bow and arrow back. Tenny was my student at City College in San Francisco in 1980. Got into conceptual physics. It spurred her on. Today, she's a design engineer at Jet Propulsion Labs in California, at Pasadena. And she's working on these flyby missions and all that stuff. And right now, she's doing what? You're making a pod for to fly in the next space shuttle. And that's what she's doing. Okay? Tenny, hold these up and tell me which of those two has the most mass. They feel about the same. Yeah. These are the same weight, gang, okay? But I want you to do something else, Tenny. I want you to hold it at the midpoint and then rotate it like this. And now try this one. Any difference?
This one's harder to rotate.
Very much harder. Take them both and do it.
Knock something out here.
Yeah. You can really feel the difference? Let's try this. Put this in your hand. Flip it like this. You do it like this. Flip it. Okay, now change, gang. Now change. Oh, huh? Guess how the lead is distributed inside here. Thanks very much, Tenny. Guess how the lead's distributed, gang. Guess where it's closer to the center. Take a guess.